Hey, welcome to the briefing. What I'm going to cover with you today is this. Before you blame the operator, inspect the first piece check. I want to take this one into manufacturing because this is one of those environments where the defect shows up after the decision was already made. The line is running, the schedule is tight, the changeover is marked complete, the first part looked good enough to move, the operator said the machine was ready, quality was covering another line, maintenance was tied up somewhere else, the supervisor needed output. Then, 2 hours later, the problem becomes visible. A measurement is out of tolerance. A seal is weak, a label is a little off, a torque value starts drifting. A component is not seating the same way every time. A surface mark appears. The batch goes on hold. Scrap starts climbing. Rework starts stacking. The shipment gets tighter. The report shows bad parts after changeover, and the first explanation starts forming fast. The operator missed it. Maybe the operator did miss it. That happens. Operator accountability matters. Following the work instruction matters. Setup discipline matters. Inspection discipline matters. If somebody skips a required step, that has to be addressed. Well, let me be direct about that. This is not a defense of careless execution, but it is also not leadership to blame the operator every time defects show up after changeover before you inspect the first piece check that was supposed to protect the run. That is the part I care about in this briefing. The defect does not always begin when the bad part is found. It may begin when the job packet does not make the change requirement obvious. It may begin when the setup sheet is technically current, but hard to use under pressure. It may begin when the gauge is available somewhere in the department, but not staged where the decision is being made. It may begin when the quality check confirms one acceptable part, but does not prove the process is stable. It may begin when the line is released because the first piece passed, even though the next several pieces would have shown the drift. From a distance, all of that can collapse into one sentence. The operator missed the first piece check, but that sentence may hide the real failure point. That is where close-up analysis matters. Close-up analysis is the discipline of getting close enough to inspect the exact part of the process where setup, material, method, machine, measurement, and inspection standards stop matching each other. It is not a broad read. It is not production needs to slow down. It is not quality needs to catch more. It is not operators need to pay attention. Those statements may carry some truth, but they are too general to correct the release point. The sharper question is this: where exactly did the first piece check stop protecting the run? Think about that for a second. A setup can look complete before the process is stable. A work instruction can look current before it matches the actual job risk. A machine setting can look correct before the material responds under speed. A sample can look acceptable before a defect pattern appears. The first piece check is where all of that gets tested. It is where setup becomes commitment. It is the point where the operation says, we are ready to run this order. That is not a small moment. That is the release decision. I have learned to respect that kind of moment because a bad release can look reasonable when you are standing inside the pressure. The line has been down. The next order is waiting. Planning is asking for recovery. The customer shipment matters. The team wants to prove the changeover is done. Nobody wants to be the person holding the line for what looks like a small concern. So the first acceptable part creates confidence. But confidence is not the same as control. A first piece can pass while the process is still unstable. One good part does not always prove the run is safe. It may only prove that one part under one condition at one point in time looked acceptable. If the check does not focus on the part of the job most likely to fail, it can give the team permission to run while the real risk is still sitting inside the process. Picture a mid-sized component manufacturing plant. We will call the production supervisor Nadia. Nadia supervises line 3 during the afternoon shift. The plant produces assembled parts for industrial customers. Several product families run across shared equipment. Some jobs require different tooling. Some need customer-specific labels. Some require a different torque value, adhesive pattern, fixture setting, insert orientation, date code, seal strength, or measured feature. The work is not random, but it is variable enough that the details matter. Over the last quarter, the plant has been under more pressure. Orders are smaller. Changeovers are more frequent. Customers are asking for tighter delivery windows. Experienced operators are training newer employees while still carrying production targets. Quality is stretched across multiple lines. Maintenance is trying to keep equipment stable. Planning wants schedule recovery. The plant manager wants throughput to improve without letting scrap and rework climb. That is a familiar manufacturing tension. Run faster, but do not lose quality. Change over more often, but do not miss the details. Train newer people, but keep output moving. Protect the customer, but recover the schedule. Every one of those pressures is real. The problem is that all of them meet at the line when it is time to release the next run. Line 3 is switching from one customer order to another. The product looks similar to the previous run, but the new order has a different insert, a revised label location, and a tighter tolerance on one measured feature. That is important. The job looks familiar, but it is not the same job. The change is small enough to be missed and important enough to create scrap if it is not controlled. The changeover is supposed to take 45 minutes. It takes 70. Planning is already asking for an update. The customer shipment depends on the run, starting before the end of shift. The operator completes the setup. The setup sheet is signed. The first piece is pulled. The operator checks the part visually. A quality tech is called over. The measured feature is checked once. The part passes. The line starts. 2 hours later, quality finds that several parts are outside tolerance. Some can be reworked. Some have to be scrapped. The customer shipment is now at risk. Now the first fix feels obvious. Coach the operator. Tell the operator to slow down. Remind the team to follow the first piece inspection. Tell quality to verify more carefully. Tell the supervisor not to release the line too quickly. Each of those may be reasonable, but Nadia notices something important. This is not happening randomly across the plant. It is showing up after changeovers on jobs with similar-looking parts and customer-specific requirements. That pattern matters. When defects keep appearing after the same transition point, the leader should not stop at the operator story. The leader needs to inspect the release point where the line moved from setup into production. So Nadia gets closer. She does not rely only on the scrap report. She walks the sequence from changeover to release. The job packet had the correct customer order. The setup sheet was printed from the shared folder. The operator used the same fixture from the previous similar product family. The insert looked nearly identical. The label location changed by a small amount. The tolerance changed on one feature. The gauge was available, but it was not staged at the point of use. The first piece was pulled before the machine had run long enough to settle after adjustment. The operator checked the visible features first. The quality tech measured the required feature once. The first piece passed. The line was released, but the next several parts were not checked in sequence. Now the issue is clearer. This was not only operator attention, it was release confidence built on a thin check. The first piece passed, but the process was not proven stable. The inspection looked complete, but it did not match the actual risk in that changeover. The job looked similar, but the change feature was exactly where the failure formed. The first piece check did not fail because nobody cared. It failed because the check did not get close enough to the risk. That is the difference between a short read and a useful read. A short read sees a bad part. A useful read sees the point where the release decision became weaker than the process risk, and that is the leadership test. Are you reacting to the defect because it showed up in finished product, or are you inspecting the first piece detail that allowed it to move forward? Once Nadia gets close enough, the small things become operationally important. The setup sheet was technically right, but the change tolerance was not easy to spot. The product family was familiar, so the team treated the job like a low-risk changeover. The operator knew the line, but not the specific customer requirement that changed. The gauge existed, but it was not staged where the first piece decision happened. Quality checked the required feature, but only once. The first piece passed, but the process drift appeared after several parts. The supervisor was watching downtime. The operator wanted to prove the setup was ready. Quality was trying to support multiple lines. Planning wanted the order moving. That is how a defect passes through. not always from one dramatic failure, from small details that are individually understandable and collectively weak. Similar part, change feature, limited sample, loose gauge staging, rushed release, one-time measurement, unclear risk signal. That is a stack. And when the stack finally shows itself, the operator becomes the easiest target because the operator is the visible person at the machine. But the visible person is not always the whole cause. Now, let's be fair to the operator. Operators work in the pressure. They deal with the actual machine, the actual part, the actual material, the actual adjustment, and the actual output. They do not operate inside a clean diagram. They are expected to follow the standard, keep the line moving, catch defects, respond to variation, support changeovers, and communicate when something does not look right. If the job looks almost identical to the previous run and the change feature is not made obvious, the operator may not see the risk the same way leadership sees it after the defect report arrives. Let's be fair to quality too. Quality is often stretched. A quality tech may be covering multiple lines, checking holds, responding to defects, supporting inspections, and answering questions from production. If quality sign-off becomes a quick confirmation instead of a real process check, the protection gets thinner. That does not mean quality does not care. It means the sign-off moment may have become too routine for the risk it is supposed to control. Let's be fair to the supervisor. Nadia has schedule pressure. She is trying to recover from a changeover that already ran long. She is watching downtime, staffing, quality risk, customer commitment, and the reality that every extra minute at changeover affects output. A supervisor can feel the pull to release the line once the first piece passes. That pull is real, but a release made from pressure can buy speed and pay for it later with scrap. Let's be fair to planning and the customer side as well. Planning needs movement. The customer needs the order right and on time, but pushing the line before the first piece check has truly protected the run can create the exact delay everyone was trying to avoid. You save minutes at release, then lose hours in containment, sorting, rework, scrap review, customer communication, and schedule repair. That is why the first piece check is not just a quality activity. It is a business control point. It protects throughput. It protects customer trust. It protects labor. It protects material. It protects the schedule from false recovery. It protects the operator from being blamed for a weak release system. When leaders only inspect one side, the correction gets weak. If Nadia only coaches the operator, the line may improve for a day or two. The operator may slow down. The first piece form may get more attention. Quality may double-check a few more parts. Supervisors may repeat the standard in the shift meeting. But if the first piece process is still thin, the same risk comes back. The next similar job may still hide the change feature. The next gauge may still be away from the point of use. The next release may still happen after one acceptable part. The next newer operator may still miss the customer-specific requirement. The next quality tech may still be stretched across too many lines. That is the cost of fixing from too far away. A broad reminder will not make the revision difference visible. A warning to be careful will not stage the gauge at the point of use. A note to follow the process will not help if the process checks the wrong risk. A production push will not recover time if the line has to stop later for rework. A first piece check cannot protect the run if it does not inspect the detail most likely to fail. So what does Nadia inspect? She inspects the release point from multiple sides, not to create a slow, bloated review for every job, not to drown the line in paperwork. She inspects the sequence that turned changeover into production. Job packet, revision check, material confirmation, tooling change, fixture setup, machine setting, gauge availability, first piece pull, measurement point, sample timing, quality verification, release decision, early run confirmation. Then she asks where the process loses control. Does the team know what changed from the last run? Is the critical feature obvious? Is the gauge stage where the check happens? Does the operator know which feature matters most? Does quality verify the feature that carries the highest risk? Does the first piece approval prove the process or only one part? Does the line check the next few parts before full release? Does the supervisor know whether the line is truly stable or only restarted? That is not slowing production for no reason. That is production control. The most important detail may be the critical feature. In a changeover, not every feature carries the same risk. If the insert changed, the insert needs attention. If the label location changed, the label position needs attention. If the tolerance tightened, the measurement condition matters. If the material lot changed, the process response may matter. If the torque value changed, the torque check matters. If the adhesive pattern changed, the application and cure conditions matter. The first piece check should not treat every feature like it carries the same risk. It should point the team toward the part of the job most likely to fail. That is where leaders need precision, not drama, precision. Another detail is gauge staging. A gauge that exists somewhere in the building is not the same as a gauge staged where the decision happens. Under pressure, distance matters. If the tool is not at the point of use, the check becomes easier to weaken. Someone may rely on visual inspection. Someone may estimate. Someone may check later. Someone may decide the part looks close enough. That is how the process starts, depending on judgment when it should be supported by measurement. Gauge availability is not enough. Gauge placement matters. Another detail is sample timing. A first piece can look good before the machine settles. The first part after adjustment may not reveal the drift. A feature may pass once and then move as speed, temperature, material feed, fixture pressure, adhesive flow, torque behavior, or handling rhythm changes. If the defect tends to appear after several parts, then one measurement is not enough to prove release. The check has to match the way the failure forms. This is where manufacturing leaders have to resist the false comfort of a passed first piece. A past sample is useful. It is not magic. It does not replace understanding the process. It does not prove stability unless the check is designed to test stability. Now, what does a controlled correction sound like? It does not sound like operators need to pay attention. That may be true, but it is too broad. It does not sound like quality needs to inspect better. Maybe it does, but that does not name the failure point. It does not sound like supervisors need to stop rushing. That may be part of the issue, but it still does not define what release requires. A controlled correction sounds more like this. For similar looking changeovers, the changed feature will be highlighted on the setup sheet before release. That is specific. Or the required gauge must be staged at the line before the first piece check can begin. That is specific. Or customer critical tolerance changes require 3 consecutive early run checks before full release. That is specific. Or quality sign-off will verify the highest risk feature, not just the easiest feature to measure. That is specific. Or the line is not considered released until the first piece approval and early run confirmation both support stability. That is specific. And that is the difference between talking about quality and controlling quality. And let me say this directly. You do not protect production by hiding process ambiguity behind operator blame. If the operator skipped the step, call it. If the operator ignored the work instruction, call it. If the operator failed to use the gauge that was staged and required, call it. If the operator ran the line after seeing a defect, call it. But if the change feature was buried, the gauge was not staged, the first sample was too thin, and release pressure was driving the decision, then the process has to own its part of the failure. That is not softness. That is control. A strong operation can tell the truth about where the release point failed. A weak operation turns every defect into a person problem. This is where leaders need to separate operator error from process ambiguity. Did the operator skip a step, or was the change feature hard to identify? Did quality approve too quickly, or was the sample too thin to reveal drift? Did production rush the line, or did the release process fail to define stability? Did the setup sheet technically include the requirement, or did it make the requirement usable at the point of work? Did the gauge exist, or was it staged where the decision had to happen? Do not protect poor execution. Do not hide process ambiguity behind operator error. Separate them. That is how trust improves across the line. Operators can trust the setup information. Quality can trust the inspection moment. Supervisors can trust the release decision. Planning can trust that output is not false recovery. Customers can trust that the product was not pushed through a weak start. That is what operational maturity looks like. Now let's bring this back to the practical read. If you are a manufacturing leader, there are warning signs I would watch closely. If defects appear after similar-looking changeovers, similarity itself may be part of the risk. When a new job looks almost like the last job, teams may miss the exact detail that changed. If the first piece passes, but the next parts drift, the check may be approving one part without proving the process. If the gauge is available but not staged, measurement discipline will weaken under pressure. If the setup sheet is correct but hard to read, the document may be technically accurate and operationally weak. If quality sign-off becomes routine, it may stop protecting the run. If supervisors release the line based mainly on schedule pressure, production may be buying speed with scrap. The biggest warning sign may be this: everyone is doing something reasonable from their own position, but the defect still passes through. The operator says the setup was signed, quality says the first piece measured in spec, the supervisor says the line had to start, planning says the customer shipment was tight, maintenance says the machine setting was correct, the customer only sees bad product or delayed shipment. All of those can be true. That is why the leader cannot stop at one version. The leader has to inspect the first piece check where those truths were supposed to connect. That is the value of close-up analysis. It gets you close enough to see the mismatch, not to blame faster, to correct more precisely. Nadia does not need to turn every changeover into a full investigation. She needs to inspect the repeating failure point. Post-changeover defects on similar-looking jobs with customer-specific requirements. That is the pattern. That is where she puts the read. She can walk one or two examples and see where the revision, gauge, sample, measurement, and release decision stopped matching the risk. Then she can correct the detail that keeps producing scrap and rework. Maybe the correction is clearer revision marking. Maybe it is better setup sheet design. Maybe it is gauge staging. Maybe it is quality sign-off timing. Maybe it is early run confirmation. Maybe it is supervisor review for high-risk changeovers. Maybe it is operator coaching. The point is not to guess. The point is to inspect enough to know where the correction belongs. That is what separates production control from production noise. A bad part is noise if you only argue about who missed it. It becomes signal when you inspect where the release check stopped protecting the run. So before you blame the operator, inspect the first piece check. Ask what looks like operator error because the defect appeared after the line was running. Ask what may have started earlier in the job packet revision, setup, gauge, sample, measurement, or release decision. Ask whether the check focused on the feature most likely to fail. Ask whether the first piece proved the process or only one part. Ask whether the team had enough information to recognize the changed risk. Ask whether the same transition point keeps producing the same defect pattern. Then decide. Do not ignore operator accountability. Do not ignore quality control. Do not ignore schedule pressure. Do not ignore customer requirements. But do not fix from too far away. The operator matters. The setup matters. The gauge matters. The work instruction matters. The customer requirement matters. But the first piece check is where all of those pressures connect. If the same defect keeps showing up after changeover, do not stop at the bad part. Look closer. Inspect the job packet. Inspect the revision. Inspect the material. Inspect the gauge. Inspect the sample. Inspect the sign-off. Inspect the release decision. Then decide what actually needs correction. Do not blame from a distance. Use close-up analysis. Find the failure point. Move with control. Thanks for listening to the briefing.